Okay, welcome to our little math session. We're going to solve 2009 AP Calculus AB free response question, section 2, part A, number 1. This question is a graph and calculator question. So before we begin, take a moment to get out your calculators to follow along. So now take a minute to read the question and look at the graph. Okay, now let's begin. Part A wants us to find the acceleration of Karen's bicycle at time t equals 7.5 minutes. So it's very important to realize that this graph is a velocity graph. And a property of a velocity graph is its slope equals to acceleration. So for 7.5 is located right here. So it's a slope between 7 and 8. So if we go look at the math right now, you get A at 7.5 equals v of 8 minus v of 7 over 8 minus 7, which goes to 0.2 miles per minute minus 0.3 miles per minute over 8 minutes minus 7 minutes. You gotta remember those units, so it's miles per minute over minutes, which gives you miles per minute squared, and the math gives you negative 0.1 miles per minute squared. It's their acceleration. And now, part 2 asks us to use correct units. It's very important, correct units. Explain the meaning of this integral right here. Well, the first thing you have to notice is the absolute value signs and that the fact that the integral of a velocity graph gives you displacement. But since we have absolute value signs, negative area becomes positive, which yields our total distance. So this area right here is negative, but since it's absolute value, it's going to be positive. So back to the math. So first, you have established that this equals the total distance in miles at Caren Road. This gives you 1 point that this, if you establish this fact right here. In order to solve this integral, you gotta take this right here is equal to this area, and we want to minus this right here, which is equal to this area because it's a negative. Negative minus a negative is a positive, and plus the rest of this area, which is right here. So 0.2 minus negative 0.2 plus 1.4, and you calculate these values by solving the areas of the triangles and squares that are underneath here, which gives you 1.8 miles. And there's your full 2 points, one for this and another one for the answer. Now part C. Now, Karen turns around at some point in this graph, and the question wants to know what time she turned around and give a reason. So, she turns around at t equals 2. And the important thing is, since she's going in a straight road, positive velocity means she's going to the right, and negative velocity right here means she's going to the left. So, when she starts to begin, she's moving right, and she begins to slow down. And at time 2, her velocity is 0, so she stopped. And now she has a negative velocity, which means she's turning away. She's turning away from her spot, and now she's going back towards her home. So from away, home. So this fact right here helps you support that it turns around at t equals 2 minutes because v of t changes from positive to negative. The value change positive to negative. Last question, part D. Larry's velocity function is modeled by w of t, which is this function right here. And they want to know who is closer. So in order to find out who lives closer, you need a total displacement of the two graphs. So we'll start off with calculating Larry's first. So what you want to do, since it's a graphical question, you want to get out your calculator and go to y sub 1 and enter in Larry's function right here. So depending on how your model is, it may look different how you set the integral. But for the TI-83 plus, you go to math 9, and then y sub 1, comma x, comma 0, comma 12, because you want to know in the 12 minutes displacement, and you hit enter, and there's your answer, 1.6 miles. So come over here, here's your integral, 0 to 12, w of t dt, 1.6 miles for Larry. And in order to find Karen's displacement, you're basically doing the same thing for part B, but you get rid of the absolute value signs. So from in here, if we go up to part B, we had minus negative 0.2 because it had to be absolute values. But now, we could get rid of one of those negatives and have a plus negative 0.2 or just minus 0.2. So here, these 0.2's cancel. You know, for 1.4 miles away is Karen. So by comparing your two values, you get that Karen lives closer to the school. And in order to get the 3 points, you need Larry's distance from school, you need the value, and this integral. So if you show this, this gives you the 2 points. And the extra point is given, the third point is from this right here. Karen's value and the conclusion of who lives closer. Well, that's our problem. We hope you kick some butt on the AP exam because of our help. And good luck in AP Calculus. Bye!